Hello, everybody. Welcome to Make Live. Today, we're going to be talking about volume 96 of Make Magazine, our Digifab issue. And it's been a few years practically since we have done a 3D printer issue. And it's kind of been interesting to catch up on it and see what's new. And we'll be talking to some of the people involved in making new 3D printers, some of the people that have written articles in the magazine about some of the applications and some of the uses. And we kind of look forward to having you today. I want to welcome everybody who's joining us. There's a chat window on your left or somewhere getting in there. But if you want to just say hello in the chat to begin, where you're from, or what kind of interests you have, anything like that helps us to see who's joining us today. But let me just give you an overview of our guests today. I will start off with Matt Stultz, who wrote A Time for Change in this issue. And Matt is the CEO of Cocoa Press and Print Kits. And Matt was around for our first, early 3D printer shootouts, we called them, where we got them together physically and tested them. And, I'm looking forward to hearing from Matt today. We have Victoria Roznowski, and she's featured in the article, The Stone Must Flow, about really concrete 3D printing and making really large structures. And Victoria is the founder of Addit.Studio, and she joins us from Turkey. Alder Riley is the subject of a profile I wrote called 3D Printing for the People. And I think Riley has one of the great stories of entrepreneurial ups and downs and sticking with it and doing something that he believes in. And we'll talk more about that. His company, he's co-founder and CEO of Itemfarm. And then we have Steve Peterson. Steve is in the, I mentioned a conversation I had with Steve in the welcome section of the magazine. And Steve is works with Voron Design, and he has also Steve Builds. And really the idea that I wrote about in the that Steve gave to me was that people today are working on 3D printers the way that previous generations worked on cars, tinkering, improving them, making them, slightly better in important ways for their uses. And then finally, Bradley Woods. He's the founder and CEO of the Virtual Foundry. Bradley wrote an article called Never Break the Chains, and he has really been a pioneer in using metal filament. Their product name is Filament, and it allows any standard FDM printer to produce high-density metal parts. And the sample he used in this article is chainmail. So we'll be going through each of these. So Matt, if we could start with you, I will say that again, just to remind anyone, if they want to, say hello in the chat, we'd love to hear from you. I don't see anyone doing that, so hopefully. And there's also a Q&A function there. If you want to ask questions, we'll get to those eventually. So, Matt, tell us, if someone's sort of said, 3D printing hasn't changed much in a couple of years, how are they wrong?
Yeah, definitely. 3D printing has come a long way. I found it very interesting just recently. I've actually purchased 2 commercial products, one from AliExpress, one from Amazon, that both were products created in China, produced in China, but weren't injection molded. The actual casing for them and things for retail products was actually 3D printed. So we are really at a point now where 3D printing isn't just for prototyping and hobbyists,
right?
But it's being really taken seriously for actual manufacturing. So yeah, things keep progressing. The a time for change article that I wrote this time is a little bit of a play on words, though, talking about tool changers and a new kind of aspect to 3D printing. So this is the 7th or 8th 3D printing digital fabrication issue, whatever, that I have worked on for Make. It's been a long time at this point. And yeah, we definitely see the trends and the things that have changed. But one of those kind of big desires that have been out for a long time is being able to print in not just multicolor, but multiple materials. And I think we're really at a point now where that is coming into its own. There's been lots of different ways tried to make printing in multiple materials work. But now these tool changers have come out into the market that every material has its own actual print head, and that print head doesn't have to carry around on the carriage at all times, getting in the way, but the carriage goes over and picks up and moves whatever tool head is needed to be printed at that time for that material. So it really kind of expands the abilities that are out there for printing in various different materials. You aren't just stuck with picking PLA or PETG or something like that just as the only material that goes into your print. Of course, you can do multicolor with them too, not just multi-material, but some of the previous systems in the past have been pretty good for multicolor, but didn't always stand up when it came to multi-material.
Yeah. Is it making the printers more expensive though?
Yes. When you go from one tool head to 4 or 5 tool heads, there's added complexity there, added materials, things like that. But one of the things that was really exciting this year is Snapmaker, who's a company who's been around and in the industry for a while. They kind of got their start with little all-in-one machines where it was a 3D printer, a laser cutter, and a CNC machine all in one kit, and you could change out the actual heads and use different things. And they were okay, but we rarely have found those jack of all trades machines to really excel at anything. And so Snapmaker announced that they were going to come out with a tool changer, and that it was going to be a sub $1,000. I think $899. I think is the current retail price, if I remember correctly, on that. And there's some hesitance. Snapmaker hasn't necessarily always come out with amazing machines or anything like that. They were good, but they weren't really something that got us too excited. But I think back to around 2014 or so, when Prusa sent the Mark II to us for testing, and I got the Mark II in and I tested it, and I kind of held my breath for a second and ended up, this is back in the days when we were doing the shootouts, and I had some of the other testers test it without me actually saying anything, because I was like, this is a really good machine. Like, Prusa's actually produced an excellent machine, because before that, the kits were still a work in progress, shall we say. And I kind of felt that way with the U1. It came in, and from Snapmaker, it came in, and I tested it, and I was really blown away, especially at the price point. And it was really a great machine. And I kind of held my breath for a second of like, I'm going to put out this review. We're going to put it on the cover and everything else. But I hope other reviewers don't get a hold of this thing and call it trash, because I'm so surprised on this, and so pleasantly surprised on this, that there's almost a little hiccup of, is this as good as I really feel like it is? And they are shipping out to the Kickstarter backers now, and people are running them. And we have a 4 tool head, $899 tool changer that just right out of the box just prints amazing. And
That's great.
I think
That's
this is really something that's going to open up the industry for tool
yeah.
changing.
Well, great. Well, I want to introduce our editor-in-chief, Keith Hammond, who's joined us. But before I do, I want to just acknowledge a few folks in the chat from different time zones. That you're awfully brave, although Brisbane, Australia, Kit Biggs, you're kind of on the early side, whereas others are, and Eduardo from Chile. Let's see, Sophie is from the UK on the late side. Simon from Toronto, just like East Coast, basically. But thank you all for making time to join us today. Keith, talk about putting this issue together.
Yeah, you know, I mean, Matt probably didn't tell you, but he's been testing and reviewing and comparing machines for us for what?
Since 2013.
15 years? 13 years. 13 years now.
Yeah, 13, 14,
well,
yeah.
And it started when there were so few hobby level 3D printers that we realized, hey, we could probably get literally every 3D printer there is in one room. And Matt did it and got a great panel of testers and reviewers. And these were some of the first people to teach 3D printing courses, or some of the first people to start a job with a 3D printer on their desktop. But from the very beginning of desktop 3D printing, Make, and specifically Matt, has kind of had the lay of the land. So we always like
to be fair, I didn't do the first one.
Oh,
Things
sorry, you
got
did the second
screwed
one.
up. It was Matt Griffin, and I was part of the second one and on after that. But Matt Griffin, credit where credit's due.
Yeah, the first one I think was Paul Spinrad and I decided that was the thing to do. And anyway, I forget where he was working at the time. But anyway, we've been doing it for a long time. The universe has gotten too big to put them all in one issue, but you know, Matt has stayed on top of the technology and CNC machines and laser cutters, and we've seen. I don't know if we have anyone here to talk about it tonight. Maybe Sam could talk a little bit, but you know, laser cutters early on were pretty much you could buy an Epilogue, not much else.
Yeah,
we started to see price competition and decent machines over the last few years, but then Xtool has just changed what you can get your hands on and change the technologies that you can take home and learn. And so we've really been excited about Xtool for the last few years. They got a bunch of new machines. It seems like they have new machines every year. But this year they had the big Metal Fab, which is a high power CNC laser cutter and laser welder combo. They have ultraviolet lasers now. They got MOPA, tiny little desktop MOPA lasers. So it's just been a fun year. Things did seem to be stagnant for a while, and you know, we made a big deal about multi-material when the Bamboo came out. You could finally really do good quality 3D prints in multiple colors, multiple materials. But then you looked at what was getting pooped out the back of the machine or the purge towers, and it's like, oh no, you know, we're already trying to figure out how do we close the loop on wasteful plastic 3D printing, and can we recycle filament? Can we make our own filament? And then suddenly we're doubling the amount of plastic used to make prototypes and tchotchkes. So this year they finally achieved the dream, which was multi-material without wasting half your filament by just swapping the tool. And you know, in some cases it's the hot end itself gets swapped and you got multiple hot ends. But the next innovation, which is already happening, is multiple nozzles. The hot end just goes and picks up another nozzle. And so, you know, the weight that's being exchanged is just the nozzle itself. And it's just faster and more accurate and less weight on the moving tool head to be wrestled with. Anyway, this was the year when it finally came true to me. Multi-material printing that didn't waste half your filament.
Okay. I want to introduce Steve Peterson. Steve is a member of the Voron design team. And, you know, as I mentioned in the introduction, he, you know, is working on I just forgot what it was. Sorry, you'll have to tell us. But you know, as I was saying earlier, he is someone who just loves tinkering with design machines. And Max of Voron said he was sending in such good comments on the designs that he asked them to join the design team. So welcome, Steve. How are you today? I think you might be on mute.
I am. I'm sorry. I expected the background noise to be a bit much. So
yeah.
Thank you. I appreciate the invite here. I've been, like you said, I've been part of the Voron design team for almost 6 years now.
Wow.
My project I'm primarily responsible for is the Voron Trident. And kind of going along with the idea of the theme here with the tool changers and modifying printers, I brought set up two. These are both Voron Trident based designs modified with community projects and Bontex project into tool changers. So the orange one there is a tool changer using very simple off-the-shelf components made by a designer in our community who goes by Zorancho. And then the other one is the new Bontex Index tool changer system. And so, yeah, that is kind of the what I like to do. I've always, you said cars, I've modified cars for basically my whole life, rebuilding engines, making modifications, repairs, and that just rolls right into a hobby like 3D printing. There's always something to make it look better or make it go faster or make it do something different. And then
so that's a very different, you know, say getting a 3D printer and, you know, from a manufacturer, and they're all the same. The Voron is really a platform for those who want to customize and you know, just add a lot more touches to it. Is that right?
Yeah, and Voron became popular at a time when there wasn't as many good commercial Core XY or other faster printer designs out there. So kind of helped gain a lot of momentum in the community. And it's sprung off a whole a lot of groups that are basing modifications and other designs, other multicolor platforms, other whole printers that are all have some roots in the Voron designs.
Yeah. And, you know, in some ways it allows for innovation to come from the community, having a platform where people can share and try things out and get other people to try it out. It helps to spread new ideas.
Voron's really still carrying the sword of where desktop 3D printing got its start, which is the open source side of things.
The RepRap and
community, the RepRap community builds and things like that, where a lot of the industry has moved away from that. You know, Voron is definitely the group out there that's keeping that pushing along. And you know, you go to Voron Vice, and it's just one of the more fun events that happens every year because it's just a bunch of just nerds, just hardcore, like talking about this stuff in way too fine of detail, and you know, showing off these crazy things that they built, and it's a blast.
Yeah, good. All right, thank you, Steve. You know, before I see Ella Fox is from Sweden. It's 1 a.m. Thank you very much for that. That's incredible. I want to say I hope you subscribe to Make Magazine. I think Jamie's going to drop a subscription promo in the chat here, or at least a link there. But we'd love to have you. You can also buy individual copies of Make Magazine in the shed, either print or PDF. But we need you. If you're not a subscriber, we need you. We need everybody to get involved here. Let me go to Victoria Roznowski, who's featured in the Stone Must Flow article. She's the founder of Addit.Studio. She has a master's degree in architecture from TU Berlin and a master's in biodigital architecture from UIC in Barcelona. So, I don't think we don't get to talk to too many architects, but it's kind of fascinating, 3D printing and sort of on large scale being applied to building homes, all kinds of different structures. So what can you tell us about that, your experiences?
Yeah, thank you so much for having me. I also started very small, I would say, and I turned my hobby into a profession. I remember I just looked today at some images. I had a very, very bad 3D printer that was always breaking, and it was causing me a lot of headaches. And it started, I think, 2020, so 6 years ago. And I was printing on my bedroom floor. I was still studying architecture, and I was making, of course, scaled models for my studies. And that was, I think, the turning point or the moment when I realized I really want to scale it up and also build or create systems that can be 3D printed in a one-to-one scale where people can live in. And that got me very curious, and I started to go on a very long journey because, of course, I just cannot walk into somewhere and buy a large-scale 3D printing system that can print out houses. I had to slowly, incrementally increase and try to also think of ways how to create maybe larger pieces through slicing them into smaller modules and arranging them maybe to create a brick wall. I might share my screen to show maybe some examples, because I work very visually as an architect and a designer. So I hope that images might speak for itself more than my words. But let me know if you can see the screen.
It's coming. There it is.
Yeah, sweet. I brought a few projects because I work across scales, as I said, whatever printer system I get my hands on, this is what I'm going to explore. And I work also with different materials. I started, of course, with polymers, with filaments, and moved then on to ceramics. And from ceramics, I moved into more experimental materials like eggshell infused or biomaterial ceramic mixtures. And that led me to design for concrete, because the material is slightly behaving similarly. So you can print in scale and imitate concrete flow behavior with ceramics. And given my background in architecture, that was a nice combination to dive into the concrete 3D printing space and design also full-scale housing systems for this application. And I'm super hyped to see how it's continuing to grow, how 3D printing is evolving, and how the scale is increasing. And last year I was lucky enough to go to Texas and see some real 3D printed houses by Icon, and that was mind-blowing to me. I didn't want to leave because I'm obsessed with layers. When you see the different layers,
tell us
I
about
think it
that.
has such a beautiful aesthetics.
How are they being built?
So Icon has different systems. One of them is a gantry, a giant gantry 3D printer. You can see it in the magazine. And it's a whole wall system. So it's not only the concrete that they're 3D printing, but they need to integrate everything, like the plumbing, isolation, and all the detailing to conventional architectural elements like windows and doors has to be figured out. So there's a lot of research behind that also, and it's very exciting to see. So sometimes it's built in stages. So it's not only that the 3D printing is being finished, or the concrete is being printed, and then the house is being built, but sometimes the printing process needs to be interrupted. There needs to be some rebar and reinforcement being placed. It's a whole, I would say, a coordination or a choreography of construction.
Are they running conduit or something else through to make wiring easier after the fact, or is the wiring kind of laid in ahead of time?
It's a good question. They do both, I think. So sometimes you lay during, and sometimes you add afterwards.
Yeah. Clay asks if they're using rebar. Do they build sort of a platform or and then put the concrete down?
So you mean for the reinforcement? There
Yeah.
are different kinds of reinforcement that is needed. So one is horizontal, and the other one, like almost like columns that needs to be
Right.
placed inside. And then there's also the rebar that is between the printed beads. So you have one exterior wall and one interior wall of the 3D printed concrete. And you also need to reinforce, or like put kind of like anchors. It looks like staples that you put inside to also additionally add
Secure
rigor to
everything.
the print.
Yeah.
They need a tool changer there too, so they can lay the rebar in as they go.
That's
Yeah.
true. That's true. For now, or I don't know, maybe it has changed, but years ago it was manual work.
Yeah.
So it's not fully automated yet. There is
Totally.
some potential.
Right. Some of these in your presentation here, some of these are more like looks like a vase or other things that it's hard to tell at scale they are, but maybe a couple feet tall or something. Are those printed with a more standard 3D printer?
Yeah, I would say so.
Yeah.
I use a printer from Wasp, which is specifically made for clay, and it has. I'm sorry, I'm a European, so it's 40 centimeters high. I cannot
that's
convert
fine.
it in my
That's
head
fine.
very quickly.
Yeah.
So it is definitely desktop scale, and
Yeah.
yeah, this is why I work across different scales. So some of them are more interior applications of the projects.
Yeah.
Some of them are columns, anything that you can make within that 40 centimeter size is done out of the very traditional and pure way of making ceramics, I would say, with a lot of manual steps still included.
Okay. Well, that's great. What's the bottom right picture? Well, that looks like a different kind. Is that a building or is it a?
This one here, yes.
Yeah.
Yes. So this was a competition entry for Icons Initiative 99 competition, where
Okay.
the goal was to design a house that is universally accessible and below $99,000. And I was lucky enough to participate in the competition and also score first prize.
No kidding.
And,
Congratulations.
Thank you.
Yeah.
Thank you. I might show a few more images.
Oh, good. Yeah, please.
So it was designed for Icons 3D printing technology to be fully made out of concrete 3D printing. You can see their large gantry 3D printing system here at the bottom, which has enough space to even print 2 units in one print bed. And yeah, I might skip a little bit through. Like the heart of the design was to create large enough spaces for everyone to be accessible. And I incorporated some details that are only possible through 3D printing that could additionally lower the cost. So for example, you can see here in some of the wall areas, I played with the toolpath and enabled the creation of very low cost furniture by just adding like plywood. And yeah, because it was such a minimal space, I was played with different structure, like not structural, but floor plan arrangements. And there were some areas where the inhabitants could later on like customize their space. And I think I have a few more interior views. Let me skip through this. And all in all, this is the outer look of the units.
I'm glad
I think
you have a bigger picture of it. It looks good.
Yeah, thank you. I think through 3D printing, you can really create something unique. Like I was interested in creating an architecture form language that you don't really see while it is still an affordable housing design. So I think that's a beautiful link, or that is only possible through 3D printing.
Mm-hmm. Well, that's really fascinating. Kent Solinsky dropped a link to the 3D Wasp, and I remember seeing them in Maker Faire Rome. They had one set up, and it was just kind of concrete printing basically, but very, very interesting. But gosh, we have such a need for affordable housing. You'd hope that some of these things could scale up and provide a solution. Matt, did you want to mention what you dropped in there? That picture didn't come into.
Oh, I was talking about, someone mentioned that they were in Sweden, and I was and that they were hoping to see a 3D printed house there, and I mentioned that whilst Amsterdam's not necessarily right by Sweden, there's a very cool 3D printed bridge in Amsterdam that is metal 3D printed, that they basically put welding arms on the end of or welding machines on the end of robot arms and 3D printed a footbridge, and it's very, very cool.
That's nice. Okay, thank you, Victoria. I really appreciate and congratulations on your great work. Let's go to Bradley Woods, founder and CEO of the Virtual Foundry. His article in the issue is "Never Break the Chains." It's using filament, which combines metal, allows them to print something like chainmail, which he shows you how to do. Welcome, Bradley. How are you doing?
I'm doing well. My voice is a little funky, but
okay,
we'll work through it.
Yeah, we can hear you. It's all right. You got a nice backdrop for us to look at, if nothing else. Tell us, how did this idea for filament come to being?
Yeah, that's a good place to start. So the Virtual Foundry, it started as a hobby, and the name actually goes back to about 2000, somewhere in there. And my initial strategies were, the goal was to create methods of making metal sculpture without having to deal with molten metals. And I was doing lost wax castings, and I set up a foundry in my yard, and I poured aluminum and made that I made from beer cans, and or recycled from beer cans, and made some simple sculptures and things like that. The next step was I moved to brass, which has a relatively low melting point, but it just kind of kept expanding from there. And I moved into a strategy of using electroforming and electroplating. So that was my first idea on a way that I could make metal pieces without the molten metal. The next strategy I moved to was powder metallurgy, working with precious metal clays and things from that strategy. And what those are is powder metal basically mixed with a little bit of rice flour as a binder. And this was 2014, and that's about the time 3D printing became accessible. So my first printer was a PrinterBot Simple with the zip ties and plywood. And I was able to print metal with that piece. So this is a green part made on that PrinterBot Simple. So yeah, from there my quest became expanding the concept. I started out with copper powder, and that was the first one that I did, and I moved to bronze, and then moved to more and more elaborate, maybe is a good word, materials that are more complex to deal with. And since then, my strategy is just to add materials to to the scope of what we do. So currently on our website, I think right now we have 17 different materials, and essentially they're all made the same way. They're a powder bound together with PLA. So they inherit the properties of PLA. They print at about the same temperatures. But when you're done, you put them in a kiln, and raise the temperatures to the point where the particles join. And as a property of surface tension, they sinter. And yeah, so I mean that's it. That's the base story. It started out, I mean,
Right.
as a maker project, and this is
Right.
like
So it's a bit like ceramics in a way, though. It's just like you have to heat it and
yeah. In
and,
fact, it's
and
perfectly analogous to pottery
right.
and any kind of clay you have to fire. That's also a process of sintering.
Yeah.
I was going to say, does it have a lot of similarities to like precious metal clays too that people use for
Jewelry.
making silver and gold jewelry? Yeah.
100%. It's perfectly analogous to precious metal clays.
Yeah. So tell us a little bit, just to interest us in how you made 3D printed chainmail, I guess.
Right. So here's some. Oh, I almost dropped it. So here's some examples. And I like to do, when I 3D print parts, I like to make things that are very difficult to fabricate, but very simple to 3D print. And chainmail is an excellent example. Not many people have tried to make chainmail, but I have. It's torture. It's just.
So if you were to make it from metal, you're saying it would be torture, but to 3D print it, yeah.
The traditional method of manufacturing chainmail is very unpleasant and tedious, but at the same time, it takes a certain mastery of metals to do it well. So it isn't a simple thing. It's just challenging and repetitive and tedious. So, but chainmail is an excellent example of exactly that. Something that is, very challenging to fabricate traditionally, but very simple to 3D print.
Yeah, that's great. Well, it looks so good. I mean, it really does look like the real thing.
I mean,
yeah.
And when I show it to people, it's difficult for them to wrap their head around it if they don't understand 3D printing. So some people, it just kind of makes their head explode. But that's where 3D printing thrives, in situations where fabricating a part is either fantastically difficult or fantastically expensive. That's kind of where this product fits well.
Yeah, that's great. And so you sell this filament, and kind of how more expensive is it than regular filament?
Pretty substantial.
Okay.
So our copper, that's what I use as a baseline. It was the first material I did. It's what we have the most familiarity with. And bronze, they work about the same. And it's something that I've done the sintering process, thousands of times. So if you look at copper or bronze, they're about $200 to $250 a kilo. And if we go back to the comparison in precious metal clays, it's less expensive than precious metal clay.
Okay. All right. Well, thank you. Yeah, go on, Matt.
The sintering process, is that capable of being done in like a normal kiln like someone would have for ceramics, or do you have to have any kind of special kiln for the sintering?
Right. And one of the key innovations of this product is that it can be sintered in an open atmosphere. And
Okay, great.
And the technique that I use comes from precious metal clay. They bury it in carbon. So any present oxygen simply combines with the carbon and becomes CO2. So you don't exclude the oxygen, you consume it and make it something benign.
Very cool.
Okay. All right. Great. Thank you, Bradley. And I want to get to our last guest, but I just see everything kind of walking through down memory lane of their old 3D printers here. But I did, since you mentioned the printer bot Simple, I just want to give a shout out to Brooke Drum, who was one of the early folks who was trying to get 3D printing available to everybody. And
He did.
what's that?
He did. And he did it very. He did. He enabled so many users. I was so happy with that printer, and it was exciting. I actually made pieces with it that I was able to take to Lockheed Martin and show off that. They're loving it. And when I got to Lockheed Martin, they had a room filled with printer bot symbols. There was probably 30 of them.
Wow. Yeah, that's fascinating. Well, let me go to my last guest tonight, Alder Riley. And he had kind of a similar story in some ways, but I first ran into Alder when he came to San Francisco from Vermont, and he said he was driving a Prius, which he intended to sleep in for several months, and he was going to set up a 3D printing kiosk in a mall south of San Francisco. And you know, so I did an interview with him. You read it in the magazine. But Riley, welcome. You have your new 3D printer system behind you. So welcome.
Yes, that Prius is long gone, and those printers that I was using back then are long scrapped for parts. But yes, yeah. What you see behind me is one of our orchard systems. So like I think everyone else on this call, started 3D printing more than a decade ago. I think I first got my first taste of it in 2009, 2010-ish. Starting to think about technology. But what I've been pursuing for a very long time now, goodness gracious, is this idea of how do you make the technology as accessible as possible for the max number of people? How do you really get it into as many people's hands as possible? And that, requires certain constraints. So as you mentioned, back then I won't name brands here, but I had literally chopped up some desktop 3D printers and literally like soldered and bolted them together so they could fit on a mall kiosk. Because the malls the kiosk in a mall, it's about 4 feet by 6 feet ish is kind of the footprint you get. And then, all right, how many desktop 3D printers can you mash together in order to fit in there? Because in a mall environment, that's where you maximize the number of people that you can actually get using the machine. So you say, hey, cool, got this crazy machine, you've read about it in Make Magazine, come on by and try it out before you get one of your machines to sell, or sign up for a makerspace. Come on by and get cool things printed.
Yeah, so that was one of the things in the interview, Riley or Alder, that you mentioned that Bradley said he went to Lockheed Martin with parts, and you were surprised. You had a mall kiosk, and you usually served, families and kids coming up and getting toys or whatever. But you also had people from Silicon Valley coming over and asking to print things, during their lunch break, right?
Yeah. Well, so it's this fascinating thing where a lot of the internal print farms and these large companies were being taken up by the boss's personal projects. So like some guy's getting married on the weekend. All right, you're printing all the little cake toppers for all of his guests, which takes away print time from the engineers that like need to get their prototypes made or need to get their parts made. So I had name a large company in the Bay Area. I had people come and say, hey, we're working on this thing. Please sign this NDA. Can you just get this done by lunch? Because I need to have this thing printed. We've got deadlines to meet. And, my boss is making personal things on the $100,000 internal machines. So really, really quite interesting stories happen when you just say, hey, I'll print whatever. Just come on in and tell me what you need. So
Yeah.
So we made a part for the Ice Cube project. In exactly the same way, just somebody came in and asked.
I have prototyped a bunch of My Little Pony back when I lived in Rhode Island and Hasbro was there. So yeah.
Oh, yeah.
But it's funny. You'd think that they can get their own 3D printers, but then they don't have access to them.
And
Well-
that is really common, is how many companies either they don't have enough throughput because they don't have enough printers, or as companies go, they buy way too expensive of machines, thinking that that's going to be better for them than the cheap desktop machines. And then it just turns out that the cost of prototypes are so expensive that it's easier to go to the guy down the street who, built his own printer.
Yeah. So
Absolutely.
go back to Alder. You kind of designed this machine. It's now being moved into schools and things like that. And you have a rental agreement, which I think is kind of unique rather than a purchase agreement. And but one of your key ideas was to make it easier for kids to see the thing being printed, right? The typical 3D printing farm, is racks of 3D printers, and you can maybe see one row of them. But you kind of created this so that it's actually tilted to make it more easy to see from a kid's viewpoint.
So as you can see on an orchard, all of our printing processes are, it's just your bed slinger process where you've got the gantry moving back and forth. I am a huge fan of the stuff that the Voron guys and these other folks are doing with the Core XY, but in terms of maximizing the visual, the ability to just watch the process, putting the build process in a box does quite work for just maximizing the number of kids that can actually see it. We use a 15-degree angle because kids are typically a little bit shorter. So you toss this thing on a folding table and you can, the people that are vertically challenged, we'll say, can see it a little bit easier. But yeah, it's a lot of these design. I sometimes think of the difference between, let's say, like your home coffee machine versus what's behind the counter of Starbucks, or like your personal car versus like a school bus. These are separate things that are incredibly specialized. But if you just want to maximize the amount of things that are made in a given time, we're pretty happy with what we've got, and it seems to be serving pretty well with like the school districts, the Boys and Girls Clubs, YMCA's, all those folks that are using them. It's just a matter of, all right, instead of asking, all right, if you've got one 3D printer in the classroom, all right, asking the kids to queue. Now with one of these things, all right, cool, Jimmy, Johnny, Priscilla, all right, everyone gets to print their same thing at the same print their thing at the same time. So
yeah, that's great, because the throughput does apply to classroom 3D printing. But the last thing I want to have you talk about a little bit is you've adapted this machine so that you can do plastics recycling and create filament that way. Talk about that.
So the orchard system is underneath the hood. It's so we talked a little earlier about tool changing. With the orchard, you can process change. So hop off one process and pop on another one. I'll just pop a GIF here so I can actually demonstrate this easier. On this system, you can see they've got one of our plastic recycling modules and a 3D printing module. So on the same unit, you can be converting plastic bottles into filament, and on the same unit, you're also printing with that plastic that you created. Again, this is thinking to the people that are using orchards. They want to cut down on filament costs. So all right, cool. Have the kids bring in a Coke bottle, and that becomes your quote unquote mass budget for your classroom. It's this way of thinking about, again, to the idea of like your personal car versus like the school bus, thinking about the needs of a school bus. Yes, technically you can have just a ton of personal cars like lining up and ferrying the kids all around, but at some point you just need a school bus that meets the needs for a school.
So on your recycling machine, you take like a plastic bottle and you create a ribbon, you cut it into ribbons, and then you feed that ribbon into a device that creates the filament. It's really fascinating.
Did you model that after like the Recreator 3D system?
So we are. I'm a huge fan of the Recreator project. I think it's really friggin' awesome. The idea of converting this thing into a ribbon and then
Well,
filament, like 1.75 diameter filament. Our module does a couple different things. We break it into separate processes. We juggle heat management a little bit different. We are still converting soda bottles into filament. So in that way, yes. But design changes, just again for the school environment, trying to make it as straightforward as possible, minimizing the necessity of like grabbing pliers and things like that to juggle things through. But yeah.
Okay, well, fantastic. Thank you, Alder, for joining us today, and it was a pleasure to learn more about the story behind what you're doing. I want to go to Sam Freeman. Sam's an editor at Make. And Sam, you're going to talk about, you wrote a piece about the CNC machines, and then you're also talking about X-Tool. So give us some, what are you learning about these desktop CNC machines? I see already in the chat, we have a lot of people sort of DIY, CNC machines, and other people chatting about that. But,
Nice. Yeah, there's
what are we doing?
So I'm glad to be here. I was fortunate enough to get to play around with some of the subtractive processes for digital fabrication. So among the CNCs that you mentioned was the Carvera Air for the mid-range with the 4th axis module they had, and the DMC2 Mini, more traditional looking benchtop size CNC. And so I think, like Matt mentioned earlier on, with tool changers kind of coming in and really making a sea change in what people are able to do with 3D printers, I think the benchtop and desktop CNCs now, and Nestworks was mentioned in the mag too, like they're coming in now, they're getting easier to use, they're getting more and more capable. They're coming in at lower price points that's putting this capability in more people's hands. And we're going to start seeing models and stuff that people couldn't, for one reason or another, like they've prototyped them in plastic and they just got to see them in something harder and more substantial or more premium material or whatever. And these mills are coming in and they're taking over, and people are going to start making some crazy things.
And I think the great thing is like we've been discussing desktop CNCs since like the X-Carve and the Nomad and things like that, but we're starting to see machines that are more rigidly built. Like that's one of the great things about the Air, right? I did an Air review a year ago or so, but the Carvera Air has a kind of unibody cast construction that really like makes it a super rigid machine, and they're adding actual coolants and things like that, so the spindles are able to deal with cutting metals and things like that. So we're not just seeing
not on the Air. People are modding on their own coolants to it, but yes, for the rigid box,
it has
kind of looked at. They've taken cues from how 3D printers have evolved from plywood and zip tied things to being a stronger rigid unibody thing. So both on the hardware side and especially on the software side, they're saying, okay, CAM is this major learning curve that is a barrier for people unless they get really excited about the thing that they want to make. How can we make that easier and simpler for them?
And Nestworks was one of those examples, right? That we were using it. And Matt, you also covered some of these in the issue, and we can't have a digital fabrication issue without talking about lasers, and that's certainly another category that X-Tool is doing really well in. So Matt and Sam, can you talk a little bit about what we're seeing there?
Yeah, so Sam was lucky enough to go out to X-Tool's facility and get a hands on with the metal fab. I took a look at the F2 MOPA, and kind of different scales of doing the same thing. They're both lasers that are focusing in, no pun intended there, on metal fabrication. The metal fab is far more of a large scale, industrial scale, but still fairly accessible to especially maker spaces, schools, and things like that. Whereas the F2 Ultra is a desktop unit that will still cut through 2 millimeters of steel and titanium, which is kind of crazy if you think about a fairly safe enclosed system that sits on your desk that's the same size as your 3D printer, but you're cutting through steel, titanium, aluminum with laser accuracy, which is fantastic.
Yeah. Sam, do you have any comments on that, or on the laser side of things?
Just that it absolutely is amazing. And that you're right, the metal fab is a beast that's not going to go into the average person's home office. It ships in a crate. It is huge. But what is it? 1200 watts that you can get up to on that laser. But it can cut through steel. This was about 2 millimeter. It can cut through heavier if you have the right gas for it. And it uses the same software program as the smaller ones. So if you're familiar with their pretty easy to use laser cutting tools, you can get shapes cut out simply. The welding part was the thing that really blew me away. I have attempted stick welding by hand, and just trying to match up with that flow as your rod's getting eaten away. It's an art and it's a skill, and it's for a very good reason that people who are good at it spend as many hours learning it as they do. And the laser welding just cheats and makes it look like, on the first try, you can make ones that blow away anything you did with the traditional style.
And
so
the accessibility
is incredible.
The accessibility of materials on laser welding too, laser welding aluminum is always one of the more difficult things that people are trying to do, and these laser welders just, again, like you say, they're a cheat code to
That's a good way of putting it.
Welding aluminum.
It was an amazing
sensation. And dissimilar metals too.
Keith,
I was saying, it was an amazing sensation to just pull a perfect little clean bead, and the feed rate of the wire is basically pushing the tool along. All you're doing is making sure that the tool doesn't wander offline, and you get this perfect clean weld. Well, you can come back and do a cleaning pass, because the laser's programmable to do cleaning passes as well. But I've never welded at all, and I've been intimidated by the mess factor and the spatter factor, and this is the future. It's amazing. The other thing I really was stuck with the mobile lasers give you such fine control over power and the frequency of is that you can do this color work now, and this is Xtool's famous little demo, which is a Van Gogh piece. But by modulating the frequency and power of the mobile laser, you can create a pretty full spectrum of color reflectance on the finished etching. And
that's great.
In a desktop unit that's you can pick it up with a handle on top and take it in the car and do it anywhere.
Well, not the F2 Ultra. No handle on that one, but yes, it's a little heavier. But yeah.
Bradley, were you trying to say something?
Yeah, my voice is pretty crackly, but
that's okay.
I'm sold. I need to try what you guys are talking about. That sounds fantastic.
Okay, good. Hey, Clay asks in the comments, do you guys see AI removing the CAD/CAM chasm? I already play around with G-code modes, but haven't actually tried to have it build something for me. It's kind of something we're starting to see. Matt, how about you? What do you see?
Sorry, I was reading
different thing, but it's a question about is AI coming into the CAD/CAM space. I mean, we did a profile of Atom. Is it Addit.Studio AI or
Yeah.
something like that. That was like prompting
we're
an engine to draw a 3D object that then pops up and you have a bunch of controls on that. But that's not CAM.
Yeah, we haven't really seen it entering the CAM space yet. I've heard some rumblings and things like that, but it's not necessarily a side there, but definitely on the CAD side, AI is for better or worse, not getting into the politics of it all. But it's definitely here. It's definitely becoming a thing. I actually was having a discussion the other day and I'm starting to see a little bit more of this, that I think it's one of the things that might kind of bring OpenSCAD, which is back in the day a 3D modeling tool that a lot of us used before Fusion 360 and Onshape and Tinkercad and things kind of made CAD a lot more accessible. OpenSCAD allows you to actually write code to design 3D objects, 3D printable objects. But you had to kind of understand this code world. Well, guess what? AI is really good at code. And so kind of making three-dimensional objects for OpenSCAD code, but using AI to generate the OpenSCAD code is becoming kind of a real interesting workflow.
Yeah, I've done this
Bradley?
in sort of a simplistic. Oh, sorry. I've done what you're talking about in a fairly simplistic way, but yeah, you can have AI generate OpenSCAD code by describing the object. It does it with amazing accuracy. I was shocked.
So, on the, I love the OpenSCAD. There are
Getting some static from somewhere. Sorry, it's not very clear.
Tools
Go on, Riley.
Zudot and those folks, they're kind of tackling parametric design, which is probably the low-hanging fruit in terms of tackling AI 3D design. For more organic shapes, definitely one of the problems with organic shapes is a lot of the data repositories on top sourcing from video game designs. So relatively low poly things, not necessarily watertight. So the resultant shapes might look gorgeous, but they're not quite what folks would call manufacturing grade.
Agreed.
We set up some folks, like if they want to, getting a kid to type out, I want a dragon with a hat. Like that's much easier than like teaching them how to sculpt a dragon with a hat. But what we found is that, okay, that can serve as, all right, prompt that very initial organic shape, but then use that as the starting point for learning Blender or Nomad Sculpt for these things. So you're working with something a little bit different than like a Stanford bunny or a sphere as your starting point sculpt.
Yeah. All right. We are a little bit past the time here. I love seeing the comments here. I will say, just to put in a plug, we'd love to have you write for Make if you have an idea for a project, something that you can share with other people, that other people want to learn how to do. I'm Dale at make.co, Keith at make.co, Sam at make.co. You can write us and, with an idea. There's also some links off the makescene.com site if you want to submit something. But what makes us happy is to publish articles by makers, that have written up what they've learned and how they did something, and share that in either in print or online in different ways. So I just encourage you to take me up on the offer and submit a good article idea. So thank you all of you for being Bradley, Steve, Alder, Victoria, Matt. Victoria, thank you for staying up so late to share with us, particularly on the West Coast and East Coast. But we look forward to the next week we have Make Live again, and for the non 3D printer or digital fabrication projects in the magazine. So we'll have another roundup of really great guests. and you can find information of that on the makescene.com website. We'd love to have you back. So thank you for joining us, everybody, today. And again, thank you, my guests, and thank you for everyone in the audience. And glad to be here.